So, welcome to the next tutorial. Today I would like to show how to create now an actual three-dimensional terrain. Therefore, this was the project in the previous tutorial. We're gonna remove now this form, but before we gonna start, I would like to explain what I wanna do. I created a very ugly drawn graphic over here, which represents or which shows what I am actually planning to do now. A terrain always starts with a plane field, and this plane field is along the X and the Z axis, and the Y coordinates are set to 0, which will result in a plane terrain. Okay, as you can see over here, we started 0 for the X value and 0 for the Z value, and then we're gonna create some triangles in that way, step by step. And camera we're gonna put actually somewhere over here, and then we look up in that direction. And before we can start doing that, I'm gonna change some things and add some new values. So the first thing which we actually gonna need now will be a variable where we actually save our size. So first of all, the terrain width, how what we wanna be, what the terrain should be. And the second one we're gonna call length. So the terrain width and the terrain length will define the terrain, how long we would like to have it. So we simply change these numbers and the terrain will be created accordingly. So it should be a dynamic algorithm to calculate the terrain later. I also set out now the vertices count, so how many vertices we're gonna need and how many indices we're gonna need. So the first one is static int, let's call it vert count, and this equals the terrain width times the terrain length, obviously. Okay, and one more for our index. Let's call it index count, and this equals the terrain width -1 times the terrain length -1, and this times 6. Why it is that I'm gonna explain later once we are actually creating the indices, and it will be clear. Okay, one more thing I would like to add over here. We're gonna use now vector 3 variables, vector 3, to save our camera position, look at, and up vector. Let's call it camera position, camera look at, and the camera up vector. Then we have the vertices over here. We also need the indices, but we actually don't need these indices anymore. We're gonna create a total new set of. So equals null, and actually we're gonna remove the read only, and we turn this indices array, or this index array, actually into an integer. So yeah, this is everything over here. The angle, we don't want to let the terrain rotate anymore, so we don't need the angle actually. Oh yeah, are now all the variables we're gonna work with. The next step will be, now let's go down to initialize graphics. What would we like to change over here? Yeah, one thing on the vertex buffer, I just realized, I don't know why I did it. I called the vertex buffer over here, and the vertex buffer makes a copy, and it actually sets the data. So I don't know why I previously actually set the data over here. Again, this line is totally not needed. That's why let's just remove it. And also here we can actually call this a bit shorter and remove the this. So what else? The next thing, yeah, the vertex buffer we need to change here now. Of course, the vertex buffer, it has how many vertices it needs to store. We set it statically to 8, but we actually now have our vertex count. So we replace this with this value being dynamically calculated depending on the size of our terrain. So that's all the changes we need for the vertex buffer. The next thing is the index buffer. Yeah, we changed actually the type of from short into integer. We could actually leave this indices.length because yeah, it should actually be equal. Now it will be actually equal the index count, but I'm gonna replace it with the index count. So yeah, now I also would like to initialize here in the graphics at the very end our camera. So our camera will be here in set camera. I have the 3 vectors, and I would like to replace these 3 vectors with our new, and here we have it, camera position equals new vector 3, and we give it the value of 2 for x, then 4.5 and float, and minus 3.5. 3.5 is set up. Okay, float. Then the camera lookat is also new vector 3, and the values will be 2, 3.5 float, and minus 2.5 float. What does this say? Yeah, simply on the x-axis we move the camera a little bit to the left, so our camera will be 1, 2, somewhere over here to the left. It will be at 4.5 on its epsilon on its y-axis, which means if we would keep it on 0, we would look straight onto the terrain and we actually would not see it, so we need to move a little bit upwards. And this one is minus 3.5 on the z-axis, so we go over here, we go a little bit up, we can't see it now because this is actually the bird's perspective, and we go a little bit into minus, so somewhere down here at minus 3.5. And from here we're gonna look on the terrain, and now the lookat vector is also now at 2, but not at 4.5, but we actually look a little bit down from 4.5 to 3.5, and we look a bit to the front at minus 2.5. So when our camera position is somewhere over here at a height of 4.5. We're gonna look into that direction at yeah, 3.5. So we have a little bit of an angle downwards, and this will show us the whole terrain in our view. As long as we keep the terrain that small, obviously. Okay, and the camera up position, the camera up vector actually is a new vector. And what this does, we keep it on our basic or on a standard value, and this simply says in how the camera is actually, no, where is the top of the camera. So the camera is, its orientation is simply, that's the basic gravity, kind of. If we put the camera and on the y-axis it's the top. If we would tell actually the x-axis is to be the top, then the camera would lay down 90 degrees. And if we change this here to -1, then the camera would be obviously upside down, and yeah, that's not what we want. So we leave it simply to a natural 1. And yeah, let's use this already in the camera settings. So for the look at here, we're gonna give our camera position a new vector, then this one will be a look at camera look at, and this one was the up vector, cam up. So further, the next thing, after we set up the camera, we gonna go and generate some vertices. So the first thing, obviously, we don't need these vertices anymore, because we need to generate them somehow with an algorithm, so we can produce them dynamically. And additionally, this part we're gonna move into our new function. So we remove all the vertices, we don't need them anymore, and down here we create simply 2 new functions. One is called private void generate vertex, and we're gonna copy this because we need a second one, and this one we call generate index. So we simply wanna produce an we're simply gonna write an algorithm to produce all of our vertices dynamically and all of our indices as well, always according to our terrain size, and which is defined over here. And these two we would like, of course, we need, before we fill the vertex buffer and the index buffer with its values, we need to call these methods to actually produce the vertices and the indices before they will be written into our vertex and our index buffer. So index buffer cam, everything is set over here. Yeah, as I said, the vertex creation, we're gonna already move down and create the vertices in our generate vertex, and the size of this array will be obviously our vertex count. So okay, index buffer, indices, perfect. Yeah, the same we need to actually do with our indices. So the indices are being created over here, and now we need to create that array in here. Indices equals new int array and indices index count. So equals new index count. So okay, now it kinda becomes a little bit. Now let's focus on our generation of the vertices and our generation of the indices. The first, we would now to have a plain field of our vertices. I go back to this poorly drawn graphic. We are now in the bird's perspective, looking from top onto our plain terrain field, and our vertices are all these red dots. So this one is vertex 0, this one is vertex 1, vertex 2, vertex 3, vertex 4, then this one will be vertex 5, vertex 6, vertex 7, 8, 9. And so we're gonna give them their own order. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. So it will be always the first vertex is over here, and a two-dimensional field is perfectly represented in a double loop, a for loop inside a for loop, so we can easily build this up. And how we're gonna do that? Yeah, simply we need a for loop first. The outer one will be, we don't call it I, but we call it actually set, because then it's a bit more logically. The outer one will always, we're gonna create this line on the X in the inner for loop, and then we jump up into the next line, and so the outer for loop is always jumping from here to here to here to here on our set axis. So we simply call this set smaller than our terrain. Let's choose the width, and set plus plus, and our inner loop will be then our x smaller the terrain length x plus plus. So we go around, and inside here we need to create now our vertices. So, and now for that, our vertex, what is the, how can we count the vertex up always one by one? Because it would work for the first line if we would choose x over here, but x will be resetted to 0 in the second. So we actually need another count variable, and we're gonna call it, we just define it over here, k equals 0, and at the end k equals 0, and here at the end we always add k plus 1. So k is always increasing throughout both for loops, and so we can use the k of each vertex to tell one vertex after each other and give it its positioning. First of all, yeah, let's do the position of the vertex equals a new vector 3. And what are the values now of the position? Obviously the inner value will be the x, and our y will stay at 0, so we have a total plane terrain. We don't give it any height information yet, that's why the y stays at 0, and the last one is the set. And simply we count this up, and this will be our positioning of each vertex. And yeah, k++. One more thing we need, because we have the position information, and now we still need the color information. So the vertex on position k color equals color dot white. Let's paint it all white. Of course, we need to transfer it to an integer, this function. And I don't do positioning and coloring in one line, simply because maybe at one point we would like to add some new data, and to not rewrite the whole line, we simply can add later a normal vector or a texture informations to our vertices if we would like to change that. So this should actually do the trick and create all of our vertices. It's not big of a deal. What did I write? What is problem? I have... Oh yeah, of course we need to set it to 0. A equals 0, x equals 0. So we need to start counting, of course, from 0. And that's it. Okay, and now to a little bit more complicated part. We need to write now a super long index list, so to say, of how to draw the triangles. And therefore, I go first of all into this graphics, and the triangles, we will start over here. We need this triangle, then we need to skip the whole vertices from here and go up to that vertex. So the whole length we have to add up, go up to this vertex, which will be the second of the triangle, and then the whole length added plus 1, and this will be our first triangle. And the second triangle, we go back to our original vertex, we go up over here and draw this. It is very important that we stick to one direction. So either we choose to go clockwise or counterclockwise. It doesn't matter, but we should paint both of our triangles in the same way. If we would mess this up as soon as we would change our cull mode into clockwise or counterclockwise, it would only always show one set of triangles from one perspective, and we move below the terrain, it would then show us the other one. But if we if we wouldn't mess up the orientation, then we have no problems with that. So we're gonna start over here, go up there, go up here, and that's the first triangle, and then we start over here, go up to that vertex and go up to this one to set the second triangle, and then we move to our next square. And what does this mean for us now? I have now presented this whole thing in actual numbers, maybe a bit easier for us to figure out now our actual algorithm which we need. So index count of vertices. We have our terrain length of 5 and our terrain width of 5. In that case, we would start with the vertex on position 0. Then the second vertex for the triangle will be the vertex on position 5. So the second index should be 5. So I counted it already, I wrote it down already down here. And the third one will be 6. So from here up, we go up here to 5 and we go here to 6, our first 3 indices. Then the second set of is 0, 6, 1. Okay, in that order and in that order. So we write it down. Our index buffer will get the information of 0, 5, 6, 0, 6, 1. After that, we're gonna, so we need to set up 6 indices. 6 indices in a row with that matter. So the first index is simply 0. The second one is 0 plus actually our length of the terrain. 0 plus 5 equals 5. And this third one is 0 plus the length of our terrain plus 6. And that's what we're gonna do. Let's draw the first one. So we need our indices, and the first index, so the first one would be 0, this one equals 0, obviously, and the second one, now let's implement already a for loop to count it up. For loop, here we can call it I equals 0. We start from 0, then I smaller than the actual index count, and I plus equals 6. That's how we're gonna do it. Y plus equals 6, because inside here we're gonna set up all 6 indices for one square. So the first index is I on 0, and this equals we need now a second variable here, integer k equals 0. So this equals k. So when we enter the loop, the index on position 0 will be 0. And in the next line, we're gonna draw the first triangle. So index of the first of 0 plus 1 equals k, which is 0, plus the length of our terrain, terrain length, and that's it. And the third one is actually e plus 2, and this equals the k, which is 0, plus the terrain length plus 1. So now we drew our first triangle. So e stays the same, and e will always then skip 6 numbers. So here 1, 2, 3, and now let's draw the second triangle, which is 0, 6, 1. And this one was the terrain length plus 1, and this is simply k plus 1. So indices I plus 3 equals k, and I plus 4 equals I plus 4 equals this one, k plus terrain length plus 1, and the last one will be k plus 1. So in our first set, when k is 0, 0, 0, 0, 0, 0 plus 5 equals 5, 0 plus 5 plus 1 equals 6, again 0, 0 plus 5 plus 1 equals 6, and 0 plus 1. And down here we're gonna increment k by only 1. As you can see, I will be always incremented by 6, but we actually need now another thing. So our indices, we have, oh, here we need one more, I plus 5. So 1, 0, 1, 2, 0, 1, 2, 3, 4, 5, and then the loop starts again, goes 6 up, which means 5, we were here, here we will be done 6, 7, 8, 9, 10, 11, jumping up another 6, and k always just increments by 1. So this would do already the trick for, let's say, the first, for our first square. Now we have made our first square. If we would like to continue, now then in the next round of our for loop, k will be plus 1, which means k is then 1. And then we count everything with 1. So 1 plus the terrain length, which is 5. 1 plus 5 equals 6. Or 1 plus terrain length plus 1 equals 7. So we go over here, and this is the first triangle, so it obviously works. K is 1, 1 plus the terrain length 7, 1 plus 1 equals 2. So even in the second loop, we have the second square perfectly set up. In the third loop, it works again. Let's check here. Here's the third loop. It's 2, 7, 8, 2, 7, 8, and 2, 8, 3, 2, 8, 3 to draw the second triangle. And we again increment k plus 1, which is then 3. And then 3 plus 3, 8, 9, 3, 8, 9, and 3, 9, 4, 3, 9, 4. But now is one more little thing which we need to be aware of. As soon as we would now increment k plus 1, it would be then 4. And from here we cannot draw a square anymore, simply because it stops over here. So if k would be 4, and we go up to 9, and then the third line would do 4 plus 5 is 9, plus 1 is 10. So it would draw us actually a triangle with 4, 9, and 10. So a total out of proportion triangle. So we don't want this at all to happen, 4, 9, 10. So we need to simply skip as soon as we get to the end of the line. We need to skip 1 k, and we need to jump up with the k to the actual 5. So 5, 10, 11. From then on it would work perfectly again to draw our square over here, and then the next square over here. So as you can see, k is 0, then here k is 1, here k is 2, here k is 3, and then we would need to skip it, so increment k 2 times, so we can skip 3, skip 4, and would instantly continue at 5. And this goes on further on, and therefore once we increment k, we need to check if we have to increment it actually a second time, and this is what we're gonna do. Therefore we need another one, I call it L for the length, and we simply always next to k we count up the length of our terrain, and as soon as this length L equals actually the terrain length, -1, because as soon as we hit the 4, when the terrain is 5 long, as soon as we hit the 4, then simply set the L back to 0. So in the next line we start all over again and simply increment the K a second time. So in that case, when the length, when the end of the line is reached, set that variable back and increment K a second time. So 1 + 1 + 2. And that will do us the trick. And that's it actually already. Did I forget anything? I think not. In the beginning told you that I will explain you how do we get actually to our index count, and now we can explain it a little bit better, because we need to calculate now how many indices do we actually have here. I mean, I didn't write it any further. It would continue down to the very end until we really drew the whole field. So how many would we need with only having our terrain length and our terrain width knowing? Plus we also know that each line has actually 6 values, and that's why we multiply it with 6, and simply one of such line needs 4 4 columns, or one of such column needs 4 lines. So this creates the first set of squares and is 4 long, and if we, which creates our first set of 1, 2, 3, 4 squares, and we have here another 1, 2, 3, 4 squares, and another 1, 2, 3, 4 squares, and here we have another 1, 2, 3, 4 squares, and so we have it 4 times, which means it's terrain length -1, terrain length -1 multiplied, so 4 times 4, and then we have the length of all lines, and this we multiply with 6 to get then actually all indices, and that's how we calculated our index count. Okay, indices are being created. It's actually, if you think it through step by step, not too complicated. Vertices are being created. Now these two methods are being called up here. We create the vertex array, we create the index array, and both are being stored now in our vertex buffer, in our index buffer, and it should draw us our terrain already. Here we're gonna counterclockwise, should be fine. We actually can set it to none, but leave it at counterclockwise for now to see if the orientation of both of the triangles is actually right. I'm gonna change actually the color of our background into black. What else? Yeah. Okay, previously we had this draw box method, which we used to draw our method, our box, and we could call it 2 times. We actually don't need this anymore. Also the float angle we don't need anymore, and here we're gonna draw now our terrain. So we actually only would need this line. We don't wanna do anything with the matrix, so I'm gonna cut this out. I put this over here. We don't need this draw box at all anymore. Do we have to change here something? Draw index primitives. It's okay. Base vertex is 0. We start at 0. Base min vertex index is also 0. The number of vertices, obviously, we need to change into our vertex count. And what's the next one? Start index. We also start at 0 with the indices. And how many primitives do we have? Yeah, obviously as many indices as we have, like the index count, and always 3 indices will form one triangle, and one triangle is one of these primitives. So index count divided by 3 should do the trick. So what else? Let's start it and see. Whoa, we got the terrain. We don't see the triangles, sadly, because this whole render state is set to solid. And let's just change it so we have a better look at it. Over here, when we set up our camera, we can set up the render state and the fill mode into fill mode. And here we have 3 options. We can show all the vertices as points, we can connect them into a solid field, or we just show the wireframe. And this should show us now our triangle field. As you can see, the camera is positioned very well, 1, 1, 2, and a bit to the back, and we look from the top a little bit into an angle on our new field. As if I would now change the size, let's just make the terrain a little bit smaller by 1, for instance, or simply to 3, and here no, the width we make it a bit longer but a bit more narrow, and it calculates our terrain. So here we have 3, 1, 2, 3, and 7, 1, 2, 3, 4, 5, 6, 7. And it's a very, very nice terrain. We could actually increase this now as much as we want. We won't see now the whole terrain anymore, simply because it goes now in a very huge field. Maybe we change the camera perspective now. Nah, let's do this later, but let's go back. 6, what did we have? 5 as a terrain. Yeah, this was a short introduction into how to actually write an algorithm of creating a terrain in a 3-dimensional world. This is what we did down there. And to actually create now natural terrain, the only thing we would need now is to have a different algorithm simply for our y and yeah, for the last coordinates. So x and z will always remain the same, and only our height needs to be changed for each vertex according whatever algorithm we would like to take or choose. And one simple thing which we could do would be now to create a random number and give a random value to each height, so it would be a little bit of a bumpy terrain. Or we could simply use a height map and take each pixel color information of a height map and give it to our vertex, which is actually very easy, just done in 3 or 4 lines of code. Yeah, thank you very much for watching this tutorial. I would like to continue the next time to actually move our camera with some user input, with some keyboard, some basic camera moving around, so we can actually move already in our three-dimensional world and discover our new terrain. Yeah, thank you for watching. See you soon.